thanks for listening. I'm Ty Whitman. I wanted to put together a little video to talk to you about breakpoint chlorination and the breakpoint curve. Now, I talk about this in my podcast, my Water Seafood podcast. It's podcast number 10, Biological Contaminants and Disinfection. However, in that podcast, it didn't afford me the opportunity to actually give you a visual representation, so I wanted to go ahead and do that right now. Now, some people have a hard time grasping this, but when you see it and when we go over it, you'll understand it's really not that difficult. It's pretty simple. Breakpoint chlorination, I should start by defining that. And breakpoint chlorination is basically the process of adding chlorine to water until all the demand in that water has been satisfied and you have a free available chlorine residual. And you want a free available chlorine residual because this form of chlorine residual has the greatest disinfectant ability, as opposed to chloramines and other types of chlororganics that might be in the water at the same time. So let's start by talking about that. Here we have our graph or our chart or whatever you want to call it. At the bottom we have our chlorine dose. This is the amount of water or chlorine that we're applying to the water. Over on this side we have our total chlorine residual. So you start adding chlorine to water this way. And as you initially start adding chlorine to water, nothing happens. You don't see any chlorine residual at all. And this is because chlorine initially, when you first dump it in the water, there's a lot of things, there's that demand. So it starts combining and reacting with substances and organics in the water right away. So you don't see any chlorine residual. Then what happens as you continue to add chlorine, you start to see a rise, slow rise in the residual. And what's happening at this stage is the chlorine is combining with ammonia in the water, it's combining with other organics in the water to form chloramines and other chlororganics. They have a disinfecting ability, they provide a residual. This is not as strong of an ability as a free available residual chlorine. So these will start to form, and there'll be a point when they'll taper off, because what's going to happen is as you continue to add chlorine, initially you add chlorine, it starts making those combinations with everything and gives you these chlororganics, these chloramines that have a disinfecting residual. But as you continue to add chlorine, what happens is that chlorine in the water reacts with the chloramines, with the chlororganics, and actually destroys the chloramines and chlororganics. I'm going to try to keep it simple for the purposes of this video, so I'm not going to dive into all the chemistry behind it. But what you need to know is the chlorine, the chloramines, the chlororganics, they react with each other and actually cancel each other out. So even though you're adding more chlorine, your dose actually starts, your chlorine residual, starts to drop back down. Your dose is increasing, but your residual drops back down. Now you're going to reach a point at the bottom here as you continue to add that chlorine when all of those reactions that were going to take place have taken place, and the demand of the water has been satisfied. So everything that chlorine is going to combine with, that's going to take up that chlorine, is done. That's called your break point, and that is the point that your demand has been satisfied. So if you were to draw a line down this chart, that's your demand. That's your chlorine demand, and they also refer to that as the break point. When we refer to breakpoint chlorination, we're talking about we want to add chlorine past this point of breakpoint, because once you hit that point where you're passing breakpoint chlorination, you've passed the breakpoint, you've passed the demand. Now as you continue to add more chlorine, you're going to see a residual that's going to rise in that water in relation to the amount of chlorine that you add to that water. More importantly, you're going to develop a free available chlorine residual from that point of breakpoint on. So initially you have nothing. Then you start developing your chlororganics, your chloramines and so forth. Then as you add chlorine, they start to cancel each other out. You hit that break point where the demand has been totally satisfied. And then as you add more chlorine, you're going to develop a free residual. You're still going to have the total, you're still going to have, I should say, the combined, chlorine down here with the chlororganics and the chloramines, but from that break point on, you're going to start to develop a free, available chlorine residual. And that's what you want to get. That has its highest disinfectant ability. And pretty simply, that is the breakpoint curve. Now, there are some things that I want to talk about that's related to this. A lot of times people in the water industry, we take residuals when we sample throughout the system. We test for free, and a lot of times you'll test for total chlorine. So I just want to use this to point out, when you're testing for free residual, this is what you're testing for. That amount past the breakpoint, that amount of free chlorine that's in the water in just Cl2 form. When you're testing for total chlorine, you're testing for a combination of your combined chlorine. These are things that have some ability to disinfect in the water, and you're testing for your combined and your free together. So total is a combination of your combined and your free. I also want to point out with this chart here, one thing, that care must be taken when you're using chloraminated waters and you're mixing those with water with free available chlorine or just pure chlorine, because if you're mixing chloraminated waters with water that has a free chlorine residual, initially you can actually have a drop, and those two can actually cancel each other out, so you can have a rapid drop of residual within the system. And one final thing I want to do with you guys with this graph is to use this, because you won't see it like this, you shouldn't see it like this if you're testing for a state exam. What you're going to see is usually multiple choice type questions, and it'll ask you something like this. It'll say something like demand, I'm going to write this up here, demand plus free residual. Demand plus free residual equals. It'll be like that. And then you'll have your answer. And your demand of the water is from here to there to breakpoint. After that, you start with your free available residual. So demand plus free available residual will equal your chlorine dose. So demand plus free available residual will equal your total chlorine dose. And same way of rephrasing that exact same question, you take your chlorine dose minus your free residual. You might see it that way. Total chlorine dose minus free available chlorine residual equals, and the answer to that would be your demand. Okay, so your total chlorine dose minus your free available residual would be the demand. Alright, so I hope that helped you out. I'm glad I was able to actually kind of put this thing together for you. If you want to if you want to hear more about chlorination, if you want to hear more about disinfection along with biological and contaminants in the water system, go ahead and listen to the podcast. You can find the Water Seafood Podcast again in iTunes, in the BlackBerry store. You can also find it on the website, Water Seafood, www. Get so sick of saying www. Anyway, water, W-A-T-E-R, seafood, S-I-F-U.com. Have a good day. Thanks for watching.